yesterday we learned about the first of the gas laws, that's Boyle's law, and it talks about the relationship between pressure and volume. Today we're going to talk about the second one, which is Charles' law. And Charles' law describes the relationship between volume and temperature. And good scientists know that if I'm going to test volume and temperature and how they're related, I have to keep my pressure and number of moles constant. I can't change more than one variable at a time, or that will affect my results. I won't know which one is causing the change, basically. The relationship between these is an inverse relationship. A direct relationship. They go up together. So as volume goes up, that's because temperature went up. If temperature goes down, volume goes down. If you own a car, or if you have ever talked to your parents about their tires, we see this in the winter. It never fails. It gets cold, and I get the alert on my dashboard that my tire pressure is low. The tire pressure, I guess I shouldn't be talking about pressure right now, but it's related to the volume, and basically when the temperature goes down, the volume, it shrinks. My tires get smaller. And that's all because of this Charles' law. And it's because the particles at a lower temperature are moving slower, and they just take up less volume. The volume goes down when the temperature goes down. Questions? Just like we said yesterday, the volume units have to match. So if this is in milliliters, this has to be in milliliters. If this is in liters, this has to be in liters. And the temperature is always in Kelvin. When we're dealing with gases, Celsius temperatures don't work, or Fahrenheit, because I can have negative Celsius, negative temperatures in Celsius, which would give me negative volumes. And a negative volume, that doesn't make sense. That doesn't work. So only Kelvin temperatures. Questions? Let's do an example. A balloon at 295 Kelvin is 250 milliliters. What is its volume at 205 Kelvin? Make a list of our variables. Initial volume, 250 milliliters. Initial temperature, 295 Kelvin. New volume, we don't know. New temperature, 205 Kelvin. Plug in numbers. 250 milliliters over 295 Kelvin equals V2 over 205 Kelvin. divide, and then multiply. $174 milliliters. That's what we would expect because our temperature went down, so our volume should go down. Let's do another example. A tire is 25 liters at 30 degrees Celsius. What temperature is required for it to be 18 liters? V1, 25 liters. T1, 30 degrees Celsius. V2, 18 liters. T2, we don't know. The first thing I have to do is deal with my temperature. It is not in Kelvin. I have to put it in Kelvin. So plus 273 gives me 303 Kelvin. Temperatures must be in Kelvin. Okay, then I can plug in my numbers. 25 liters over 303 Kelvin equals 18 liters over the new volume. Oops, I'm backwards, over the new temperature. To solve this type of problem, the simplest thing is probably to cross multiply and divide. So cross multiply, you have 25 liters times T2 equals 303 times 18, which is 54 liter Kelvin. Divide by 25 liters. And you get 218 Kelvin, because liters cancel. Lower volume, lower temperature. Questions? Okay, that's it for Charles Law. Work on your homework assignment for today.